In this video, we'll understand what Docker is and why it is so popular. So before understanding Docker, we'll try to understand how a traditional development workflow works. Okay, so let's say you're building a Spring Boot application. So normally when you build a Spring Boot application, you do a below setup in your machine. For example, let's say in your local machine, let's say using a Windows machine. So you need to install all the softwares. Let's say you're installing a Java JDK, we need to install Maven. And let's say your Spring Boot application requires a database here. We need to install the database as well. And let's say your application using a caching mechanism. So you need to install Redis also. We do set some environment variables so that our application works fine. Okay. So let's say this is a very typical setup. We have window machines here and all your software application are installed in your machine. All the configurations are set. Okay, so you write the code, you test them using your unit testing, and everything works fine perfectly on your machine. And let's say you want to test your application in a different environment, or let's say you want to share your code with the another developer for testing, or you want to deploy it in your QA environment or the production environment. And suddenly, in that specific, let's say in QA environment or the production environment, some issue happens. So this is a very famous problem. Like it works in my machine, but it doesn't work on a in the production server or in any other setup. So what does that actually mean? So your code might be correct, but the environment is different. Okay. So why environments differ? Let's say this was your setup which you in your local machine, and let's say you are testing it in QA machine. Okay. So what may happen? The environment in QA machine itself might be different. For example, let's say you are having JDK 17 here, but in your key environment you may be having a different JDK version, or you may be having a different database version, or you may be missing some configurations, Maven may not be installed, your Redis may not be installed. So you may face such issues, and the port which you're trying to use may be already used, right? So these are some of the problems which you can face in a different environment. So what does happen? So your application may fail to start, or you may get some runtime exception, or SQL binding issues you can get, or a port binding issues you can get. Okay, so these are the some common issues which you face when you try to run your code on the machine. Okay, so these are some examples which I have highlighted. So let's say Java version mismatch can happen. Okay, you're compiled with Java 17, but your server has Java 11. Your MySQL driver works locally but fails on the server. Linux and Windows file path may be different. The Redis itself may not be installed, or your app is already using the port number, or you may have some manual setup issues which you might have done. So how did we try to solve this problem? So to avoid all this problem, you could have documented all the steps. You need to install so and so softwares. You need to create the database, and you need to set up the environment variables, and then you run the application. So you documented all the steps, and you gave these steps to your operations teams or a QA team or the production teams. Okay, but it may happen that some steps might be missed by the team members, right? They may human error can always happen, and they may miss some steps, and some issues can happen in that specific environment. So what are the other option we use the other option which we tried is a virtual machine. Okay, so what exactly is a virtual machine? So a virtual machine is a full computer inside another computer. What does that mean? So if you see this diagram here, this is the virtual machine. So we have a host machine. On top of that host machine we have a hypervisor. So what does this hypervisor do? So each virtual machine has its own operating system, has its own kernel, and has its own libraries. So all of them are running on a hypervisor. So what is a hypervisor? So a hypervisor is a software that splits the hardware into multiple virtual machines. Okay, so this hypervisor is splitting this machine to multiple virtual machine, and each virtual machine is having its own operating system. So this is a typical virtual machine architecture which was there. So now we have a physical hardware, then we have the hypervisor, and then top of that hypervisor we have the virtual machine with their own operating system. So they had some benefits, like they were strongly isolated. Each virtual machine had its own operating system, but this was good for the legacy application, not for something like microservice application. So what are some of the issues with the virtual machines? So each virtual machine has its own full operating system, which can occupy a lot of space. Okay, so it can take a lot of GBs of RAM, and since it had its own OS, it can take a lot of time to start up. The startup time was in minutes, so it's not very scalable. It's not very cloud native in nature. Okay, so that is where the Docker comes into the picture. Okay, now we are going to introduce it. Okay, so what problem this Docker is trying to solve? Okay, the Docker mainly solves this environment inconsistency problem. So it tries to answer this question: what if I ship my application along with everything it needs to run? What does that mean? So instead of saying install this Java, install MySQL and configure this, you just say run this container. Okay. So what was the problem in virtual machine? So each virtual machine was requiring an operating system. But do each app really requires an operating system? It only requires a file system, network, CPU memory limits, process isolation, dependency isolations. Okay, it doesn't require the complete operating system to run. Okay, you can run multiple isolated application and they can share the same operating system on the kernel. Okay, this is how the architecture of the container looks like. You can see it in this diagram also. So we have a Docker, we have a host machine, and top of that we can have the Docker engine, and on top of that Docker engine we can run multiple containers. Note here, in the virtual machine, each of the virtual machine was having its own operating system, but here in Docker we don't have that operating system here. There all of them are sharing the same operating system using Docker engine. Yes, this is what I was referring to. We have physical hardware. On top of that, we have the host operating system. Then we have the Docker engine, and on top of the Docker engine, we have the containers. And containers are having both the application and their libraries. So why containers are better than the operating system? Because they are sharing the OS system. They don't have the operating system. Each application doesn't have its own operating system. They are sharing the operating system, and due to this it can start the containers can start in seconds, and their size is only in MBs, not in GBs, because you don't have the operating system inside. And scaling is easy in compared to the virtual machine because they're very lightweight in nature. So this is where the Docker definition comes into picture. So this is a formal definition of Docker. Docker, what it does, it packages an application and its dependencies into a lightweight portable unit called as a container. So what does your container include? It's very important. It includes your application code, your runtime, your dependencies, your OS level libraries, and all your configuration. And due to this, it runs the same everywhere, in your developer machine, in your QA environment, in your production environment. It runs the same. This is a comparison with Docker and without the Docker. No setup is required, no manual setup is required here. It's OS independent, and if you have any issues, it's very easy to reproduce. It works everywhere, and onboarding is very fast. So the key takeaway here is Docker eliminates its works on my machine problem by packaging an application and its entire runtime environment into containers, and that behave consistently across development, testing, and the production environment. Okay, these are some of the core benefits of Docker which are highlighted. Okay, which we already discussed. First is consistency across environments. Build once and run everywhere. So the same container runs on the developer machine, test server, and the production. It eliminates work on my machine problem. All your application dependency and runtime are packaged together. So there is no dependency mismatch or a version mismatch. They are lightweight compared to virtual machine because there is no need for full OS per application, and they share the OS kernel, and they can start in milliseconds, right? Because they don't have the OS full OS per application, and it's very ideal for microservice and auto scaling. And they are highly resource efficient. They have better CPU and memory utilization than the virtual machine, and you can run more application on the same hardware.